So, welcome to Lesson 8 of Week 1 of Julia Programming for Nervous Beginners. We are talking about data containers for the first time, and we'll focus on strings in this lesson. So our idea is to introduce the idea of a data container with the example of a string, and then also introduce arrays as data containers, and to use comprehension to make an array. So you should be able to say what a data container is, at least in general terms, and you should be able to extract characters from strings using indexing. You could also use a range as an index to extract a string from a string. You can explain what it means for a character to use more than one code unit, so the idea of code units will come up, and you'll see that there is a difference between the function length and encode units as applied to strings, although they in some sense measure, both of them measure how much data there is in the string. They measure it in different ways and they give different results. Finally, we'll use a comprehension to write the characters of a string to an array, and that will allow us to at least say in general terms what an array is. So what is a container? This word comes up quite often in the Julia documentation, and it's actually a slightly vague term. The idea is just that a container is something that may contain more than one value. A container itself is a value, and so a good way to define it is to say a data container is a value that may contain more than one value. And we now have an example of that. A string is a value. A string value contains more than one character, or rather it may contain more than one character. So this is absolutely essential in computers. Data is organized in containers, and all high-level languages offer you several kinds of containers. If we see a string as a container, then of course the data has to go into the container, and we've done that by constructing strings. We put characters into the string, so we put data into the container, but there is of course also the need to get the data out of containers, and that's what we're talking about today. So the indexing is the first major idea. It applies of course not only to strings but to many other data containers as well, and in Julia we use square brackets. So let me give you EG1. If I say, I need to start up Julia, and I say EG1 is a variable in this case, and I'm just going to make it A, B, D, E, G, X, Z, or whatever. It's completely unimportant what it is. All I want to be able to do is to index into it with a 1, that's A. It tells me a lot about it. 4 is C, 8. 8 is a mistake. There are not actually a position 8 that I can try and access. So in the case, so what it is that we're using square brackets, and as long as the K we use actually points to something inside the container, then we get something out. In this case, the values that we can use we have A, B, C, D, we have up to 6. And it works perfectly because in this case, each letter corresponds to one index. We can actually index directly into a string. If I make a string, so make a string please, and I want to index into that, I can say what is in position 10, and it's the R. Now, we can index part of the string. So I can index here part of the string 10 to 14, but let's use the example that we have from there. Greeting equals hello world, maybe I should say hello human, and I want to index into greeting, say from 2 to 8. And that is character 2 is E and character 8 is W. So 1, 2, 3, 4, 5, 6. The space is a character. Huh? So, yeah, 1, 2, 3, 4, 5, 6, 7. This is position 2, position 3, position 4, position 5, position 6, position 7 is a space. Position 8, the 2 to 8. So this code fragment 2:8 is a range. It starts at index 2 and it ends at index 8. And in fact, we can even use, we can assign a result to a variable. So if we say we want the initial and the last to be, say, 1 and 3, and we can say, let's not use the term range, it's actually a function, my range, that's now just a variable, is equal to from init to last, and let's just make a string, some other string, misspelled even, but doesn't matter because now again I have the square bracket, but all I need to say is my range, and that is indeed characters 1 to 3. Okay, so you can also use bigger steps. So if I, for instance, say greeting, and I want to start at character 3 and take steps of length 2 and end at character 9, say, just to do slightly different from what's in the lecture, that is character 3, character 5, character 7, character 9. Character 3, character 5, character 7, and character 9. So that is the actual values that the range specifies as 3, and then a step of 2 to 5, and another step of 2 to 7, and another step of 2 to 9. I can even make it go backwards. Of course, if I want to go backwards, I've got to start at something, and I can say, let's take that -3 to 3. So that'll be, it starts at 9, then -3 takes us to 6, and then another -3 takes us to 3. And so it starts at 9, that's 9, and then 6. So 9, 8, 7, 6, 5, 4, 3. I can actually run greeting all the way from the end. The end index is the very last index that is valid. So you can always say greeting at end or whatever, anything. End is always a valid index. So we start at end and we go -1 and we go all the way down to 1 and we have it in reverse order. Finally, it can actually, we can extract just one character, say for instance from character 4 to character 4. But the important point here is, although it's a single character, it's still a string. However, if we just extract character 4, it's a character. Now here is a difference which Julia makes completely explicit. So this is something you should know about Julia right from the start, because when you work with strings and characters, this will come up. And that is that the length of a string and the number of code points in a string are not the same. And the point is that characters have variable width. What do we mean by variable width? This remark, it just says that Julia is actually not unique in having to deal with this. This is all of the Unicode, for example, but other standards for encoding characters. Most of them, once they have many characters beyond just a few hundred, they actually allow the characters to have variable width, and then they encode it in one way or another. So in Julia, this is explicit. We have access to that immediately. And the variable width is that there can be more than one code unit in a character. Some characters have only one code unit, and in particular the characters that we used in our first example all required only one code unit. But there are characters that have more than one. So for our EG1, remember that EG1 has 6 characters, and so if we say length, that asks for the number of characters in EG1, and then that's 6. If we ask for the number of code units, that's also 6. But let us make EG2, which we make alpha beta. Now remember that if we make a string and we want to make alpha backslash alpha and then tab and then backslash beta and then tab, and those are the first 2 letters of the Greek alphabet. Sorry, I want to make this EG2, not EG1. I have already got EG1. I would have lost it if I hadn't spotted that potential mistake. And now I have EG2. So now I can ask for the length of EG2. We already know that that ought to be 2, and we can have encode. And I can just press tab to complete that, and I make that EG2 as well. And now we see that the length is 2, but the number of code units is 1. If in fact I want to ask, I can ask for the number of code units just in the character slash alpha. Oh, no, it won't actually give me the number of code units in the character. So I need to do that. Okay. So I say that encode units can take a single character as input and give its width, but it turns out that it has to be in a string. So if we actually want to index without worrying about the width of the code units, width of the characters in terms of code units, and just index into the characters directly, then what we can do is make them into an array, and for this we will use comprehension. So comprehension is a compact way of doing things that can be done in a much longer way. So let us use this particular code. I'm trying to use the word char here and the word char there to indicate that that's a variable that I'm creating for the purposes just of creating the array for inside the comprehension. So greeting array, greeting array equals, and now square brackets must be around the whole expression. And then we use char and for char in greeting. So this is the first bit of more or less tricky code that we're doing on this course. So let's look at it in some detail. The square brackets that we put in here, they indicate that the result is going to be an array. So we've had square brackets as input. For instance, if we want to index into greeting, we use square brackets. Here's another use for square brackets. They surround arrays if we use input. This is a variable. This tells us what we are going to use to make the array. So this is our kind of input data into the array. In this case, it's a variable, and it's a variable that indicates a string. So we're going to extract things from the string. Then this for-char in greeting means that we're going to take the characters in greeting one by one. That is what this for int is, and the variable char will take one after the other the values in greeting. So greeting, as you remember, is hello world. So char will first take the value h, then it will take the value e, then it will take the value l, and so on. And then it will do whatever we ask it to do over here. So this just says use the value, just as it is. Don't do anything with it beyond that. And pack that into the array. So what we expect to see is an array with all the characters from Hello World. And indeed, here they come up. But now you see it's a 12-element array because there are 12 characters, H-E-L-L-O, comma, space, W-O-R-L-D. And it's put them up in a column, which is the way that Julia displays an array with one dimension. So it's a one-dimensional array, it makes a column, and it tells us that we've got a 12-element array of one dimension, and this is of type char, but we will not talk about types yet until a later lecture. Okay, so here is the explanation that I've just gone through. So how does the comprehension work? Well, the second char that occurs in that's the second char. That takes the values in greetings one after the other. It iterates over the values in greeting, and then it uses those values, and this is actually a function. So we can just ask it to repeat, say, to repeat 3 times. And then we get strings, of course. When we repeat characters, we get strings. And so now you see that this one is an array of type char, and this is an array of type string. But they're both one-dimensional, and they both have 12 elements. So the summary is that we go over our container of data, and for every value in the container, we store it in dummy variable, and then we put a value. And whatever we put there can depend, it can be a function that depends on dummy var, or it could ignore dummy var completely. So for is a reserved keyword, in is an operator, if you want to be technical about it. Let's just talk a little bit more about arrays. They are very efficient, and that's particularly true when the elements have fixed width. So greeting array is one-dimensional because they're like a street. You can go down the street and you can index every address in the street with a single value. But it is often convenient to use more dimensions. For instance, if you have an appointment at 9 o'clock on the 13th of March, then there's the month, the day, and the time. So that's 3 dimensions. Or if you have a map with north and north-south in the one direction and east-west in the other, that's 2 dimensions. And it's actually possible to use a very large number of dimensions. In which case, if you have a very large number of dimensions, often happens that many of the elements are not used. And such an array is said to be sparse. Efficiently working with sparse arrays is one of Julia's great strengths, but it is not part of this course. The question of efficient use of arrays is something that any expert programmer has a very strong handle on. But it's an advanced topic, and the actual efficient handling of an array depends a lot on the actual problem you're dealing with. So if you've built up expertise in one area of efficiently handling arrays, and now you start tackling a different problem, then efficient handling of the arrays for the different problem might actually be quite different from the first set of problems that you're used to, and you have to relearn a whole lot of new ways of doing it efficiently. And so this is a specialization that's not appropriate for beginners. Okay, so this has been a long and technical lecture with lots of new ideas. Let's just go over them. So we have data containers, strings and arrays of data containers. We can use square brackets as delimiters to indicate the index value to extract the data from an index or indeed also from an array. We can extract it with a single integer from a string, in which case we get a character, or we can extract it with a range, in which case we get a string. And we can form a range just from some low number with a semicolon to a high number, or we can form a range from some high number with a minus step to a lower number. And the step length doesn't have to be 1, it can be bigger than 1. So if you use a range that we've already covered, the width of a character is the number of code units required to store that character in a string. Characters have variable width, and we can use the number encode units to determine width. Length returns the number of characters in a string. Code unit returns the width of the string. The comprehension creates an array by iterating over a container. A comprehension is a square brackets around an iteration. The iteration in a comprehension uses the reserved keyword for and the operator in. And here's the syntax. This is the syntax of the iteration. For the full comprehension, we need to put square brackets around it. We start with a container, we say in, we have the dummy variable, we say for, and we create the value. Usually we'll use dummy variable to create different values. So arrays are an advanced topic which we do not cover in this course, and that's the end of lecture 8.